welcome back to Michelle's version of calculus. And today is 5.3 increasing and decreasing intervals. And so, yeah, I guess it's kind of just work on it. All right. So when we know when a function is increasing, let's just draw a little picture. I like pictures. We know when a function is increasing that the slope is positive. All right. It's gonna look like that. Or like something like this. We know that that is increasing. The slope is positive, right? And when or let's add on something bit. When f prime is greater than 0, we know the slope is decreasing, or the slope of a function is negative when f prime is less than 0. And once again, this makes sense because the derivative, or f prime, is literally just a slope. You're finding a slope based on your f of x graph. You're finding the slope at a point, aka instantaneous rate of change. Is it ringing bells? I hope it is. So yeah, pretty simple. Now, in order for us to do it, I wrote the steps down here. The first step is to, find your critical points by finding the derivative and setting it equal to 0. Step 2 is to use a table or a number line to check the signs before and after each point. And 3, write statement. Yep. I apologize. Not to necessarily check before and after each point. That's more towards max and mins. But just to kind of, so you can see where the signs change from positive to negatives. And that's going to help you find your interval or your intervals where a function is increasing or decreasing. And that's exactly what our next question is. All right, example. Find the intervals on which the function, blah, 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 is increasing and decreasing and justify your answers. I already previously found the derivative, so that's pretty convenient there. And so here's our derivative, and now we're going to continue. Set this puppy equal to 0. We're going to factor it out, which is going to be x minus 5, x plus 3. And once you set both of those equals to 0, we learned that our critical points are at 5 and negative 3. So what we're going to do is we're going to put those little points into our table. We're going to put those ones in. So let me draw lines. I'll do it in black. So this is going to be 1 point. This is going to be another critical point. Alrighty, so you are going to get the point, put a critical point. We have negative 3 and 5 as our critical points. So then you're going to plug back into the original equation. So once you do that math, well, you don't want to plug the critical point in. You want to plug a number before the critical point because we know that these are both going to be 0. So plug in a number before. So let's go ahead and just do... so right here we can see... Right here we're able to tell from here to here our function is increasing, and then from here to here it is decreasing. And technically you would write a statement with justification, and it basically would be it's increasing. It'd be like I'll do an arrow, increasing from negative infinity to 5 because y or f prime x is greater than 0, and then you do the same thing for decreasing. It's decreasing from 5 to positive infinity because f prime x is less than 0. And that's kind of that there. I have a little visual here. This is the f prime graph, and I just wanted to note on this graph that when the x-axis here is going to kind of show you whether it's positive or negative. So that's the x-axis. Anything above it is going to be positive. It's going to have a positive slope, which means it's going to be increasing on the f prime graph, and then anything below it is going to have a negative slope on your f of x graph, and it's going to be decreasing. So these would be your So let me just try and show you. Right here, these would be your intervals of decrease. And then right here would be your intervals of increasing based on the f prime x graph. All right, that's it. Thank you.